Hi guys, welcome back to my YouTube channel. In today's video we are going to see about mass and weight. Before entering into our video, let me ask one question to you. How much is your weight? Your answer might be 50 kilogram. As a physics student, if you write the same thing in your exam paper, for example, weight equal 50 kilogram, then it is incorrect because weight is a force and it has the SI unit Newton, not kilogram. So, kilogram is the unit of mass. So, if you write anything in terms of weight, then you must use Newton as a SI unit. In our everyday life, we come across so many things such as a rice bag. It will be mentioned net weight equal 25 kilogram. In a soap cover, maybe 10 gram. So in our everyday life, we could see those things as a weight. On Earth, everything is experiencing a gravitational force. Actually, the definition for weight is the mass which experiencing a gravitational force. So, we use weight in our everyday life with a kilogram as a unit, but you must know that mass and weight are entirely different. If you write anything with SI unit gram, kilogram, it mention mass. If you write any value with a Newton, that is N, then it represents weight or force. Mass is the amount of matter present in an object. Weight means mass which experiences gravitational force. Weight has a formula W equal mg, product of mass and gravitational field strength. On Earth, gravitational field strength is 9.81 Newton per kilogram, or approximately we use 10 Newton per kilogram for easy calculation. So G value on Earth is 10 Newton per kilogram. So anything which has mass on Earth which experiences G value, that is 10, then that is known as weight. So remember, weight means it has mass and G value. Mass means it is the amount of matter present in an object. Right. Instrument. Which instrument can be used to measure mass? Most of the scientists, they use a balance or a beam balance to measure mass. After measuring the mass using a balance, by multiplying that mass by 10, we can get weight. So, in some cases, if they ask which instrument is used to measure weight, if you write balance, it is also correct. But directly we can measure weight using Newton meter or spring balance, etc. So I have a simple balance. I will show you. Here is a balance. I have compared the mass of this rice with some mass. So mass of this rice is 20 gram on Earth. How can we calculate the force exerting by this rice? Or how can we measure the weight of this rice? We have to change the 20 gram into kilogram because the SI unit for mass is kilogram. So 20 divided by 1000, we will get 0.02 kilogram of this rice. And just we multiply with a 10, then we will get 0.2 Newton is the force exerting by this rise. By knowing mass of any object, by multiplying with 10 on earth, we will get the weight or force of that object on earth. If we take the same setup to the moon or any other planet, will the mass change? No. The mass will never change. There also the balance will be in the same position because mass will never change to place or planet to planet. Mass will be same always. But weight, as you all know that weight equal mass times gravitational field strength. On earth it is 10 Newton per kg. When we take this setup to the moon, on moon the gravitational field strength is 1.6 Newton per kilogram. So mass will be same 20 gram on moon, but weight will be different because on moon mass will be again 0.02 kilogram after converting gram into kilogram and multiplying with 1.6 Newton per kilogram, we will get weight of this rice on moon is 0.032 Newton. So we will get the weight of this rice on moon is 0.032 Newton. On earth the weight of the rice was 0.2 Newton. On moon the weight of the rice is 0.032 Newton, which is very less because G value is very less on moon. So if we measure mass of any object on any other planet, mass will be same. Mass will never change, but weight changes according to the G value on that planet. I hope you are clear about mass and weight. Let me conclude. Mass is the amount of matter present in an object, but weight is the product of mass and gravitational field strength. Mass is a scalar quantity, weight is a vector quantity. Mass doesn't depend on any other physical quantity, but weight depends on mass and G value. The SI unit for mass is kilogram. The SI unit for weight or force is Newton. Instrument used to measure mass is a balance. Instrument used to measure weight is Newton meter, spring balance or a balance. Mass will never change from planet to planet, but weight will change according to the G value on the planet. Remember, mass and weight both are entirely different. I hope you got something about mass and weight. Let's try few questions from mass and weight. Try this first question. Which instrument is used to compare the masses of objects? Option A, a measuring cylinder. Option B, a barometer. Option C, a manometer. And option D, a balance. Your time starts now. The correct answer is D, a balance. Try this second question. The mass of an object is measured on Earth. The mass is 5.0 kilogram. The object is taken to the moon. The mass of the object is measured on the moon. What is the mass of the object on the moon? Option A, 0 kilogram. Option B, more than 0 kilogram but less than 5.0 kilogram. Option C, 5.0 kilogram. Option D, more than 5.0 kilogram. Your time starts now.
The correct answer is C, that is 5.0 kilogram, because mass will be same on earth and on moon. Try this third question. Which is the unit for force and which is the unit for weight? Your time starts now. The correct answer is D, because force and weight are same with the same unit Newton, that is N. Try this fourth question. An object has a mass of 50 kg. The gravitational field strength on Earth is 10.0 Newton per kilogram. The gravitational field strength on a distant planet is 4.0 Newton per kilogram. What is the weight of the object on Earth and what is its weight on the distant planet? Your time starts now. The correct answer is D. Let's see how to calculate the weight on Earth and on the distant planet. On Earth, weight formula is m times g, that is mass times g value on Earth. So 50 times 10.0 Newton per kilogram equal 500 Newton is the weight on Earth. Weight on the distant planet. Again the same formula, weight equal mg. Mass will be same on Earth and on a distant planet, but g value is different. So weight equal 50 kilogram times g value on the distant planet is 4.0 Newton per kilogram. So weight equal 200 Newton on the distant planet. Try this fifth question. The mass of an astronaut is 70 kilogram on the moon. What is the mass of the astronaut on the earth? Option A 7 kilogram, option B 70 kilogram, option C 80 kilogram, and option D 700 kilogram. Your time starts now. The correct answer is B, that is 70 kilogram, because mass will be same on the moon and on the earth. Try this sixth question. A student stands with both feet on some scales in order to measure his weight. The reading on the scales is 500 Newton. He lifts one foot off the scales and keeps it lifted. What is the new reading on the scales? Option A 0, option B 250 Newton, option C 500 Newton, and option D 1000 Newton. Your time starts now. The correct answer is C, that is 500 Newton. Even though the student lift one of his leg, whole weight will be acting towards the other leg. So the same weight value will be displayed, that is 500 Newton. Try this last question. Which statement about mass or weight is correct? Option A, mass is a force. Option B, mass is measured in newtons. Option C, weight is a force. Option D, weight is measured in kilograms. Your time starts now. The correct answer is C, that is, weight is a force. All other options are incorrect.
I hope you got something about mass and weight. Thank you.